Okay, thank you. So I'll talk about a number of studies in the area of science of science. And for those of you who are wondering, what is science of science? I'll just say quickly. It's really an emerging area, interdisciplinary area of research, which uses quantitative data to understand the underlying principles and mechanisms that are driving the development of scientific knowledge. I'm going to do an overview of 3 studies that I did in this area that cover different aspects of this. And one of the most fundamental questions we can have when we think about science is, how does science grow? And early studies said, well, it grows exponentially. And people have shown that, and this graph here confirms that the number of papers indeed grows exponentially. But the question I had, does it make sense to science as knowledge? Does knowledge that we have really grows exponentially? And in order to address that, we really needed to switch the focus from paper as a unit of analysis to something that's closer to science as knowledge, and that was the language that was used. And once you switch to language, you see that science actually grows linearly, which is closer to what we believe science is actually moving. This actually has implication of what it is that we are producing in lots of papers, but that's another question. Here, I'm going to actually move to another area in which I did some research, and that's really trying to understand scientific workforce and the careers of scientists. This is the work that I'm jointly doing with Filippo Radicchi here in school and John Walsh from Georgia Tech. And what we did here is, so the increased pressures on productivity, we've seen the consequences of that in the previous slide, but we also have increased team effort in doing science. More and more science is done collaboratively, and that raises the question, well, what is the then contribution of individuals in this team effort? And to analyze that, I really looked at, of all of the papers that are being done, how many of people who are contributing were ever in their whole career lead authors. And it's very revealing. While 80% of all of the scientists in the past were lead authors, today that's down to 35%. So only 35% of all the people who are publishing ever led a study, including their own PhD research, I guess, which is very interesting because it talks a lot about the expertise that we are having. You may say, well, because that's maybe because of transients, like people just publish one paper and leave, and this is showing that, yes, transients are on the increase, but they have been very stable. Then it raises the question of success in science or successful scientific careers. Most of the research so far looked at only tenure-track faculty and the impact they have via citation. But the question I have is, well, is this the best measure of success? What if the successful career is a long career, right? The first thing you need is to survive to write, and the citations come later. If you don't survive, that's it. So if you look at that, well, fewer and fewer people are surviving. The half-life of scientists is now 5 years. So actually half of all of the people who enter science leave within 5 years. That was 35 years. 35 years only 50 years ago. So it really has policy implications. And where the vulnerable population is, it's among those 65 permanent team members. People who really never led a paper are more vulnerable. They are under a higher hazard of leaving. And again, you may also, why is this important? Well, it is because that's important for science policy, because there are no venues that do allow for long and meaningful careers for people who do not go into tenure track, right? There are research scientist positions, but they are more short-term, and that is a problem. And that's something that we definitely would need to address. And finally, I'm just going to give you a preliminary results of the third study. And the third question is, well, how science works when it comes to larger units such as fields or disciplines. And this is the work I'm jointly doing with Filippo here and Santo Fortunato and Sandro Famulini. And this is the preliminary findings. So we finally have identified in physics the events of splitting and merging when it comes to fields. And we are moving this now to try and find signals of what is preceding, like what are the events that lead to merging or splitting of the fields, and can we actually in the future predict those events? And again, it's very exciting work which is underway at the moment. So thank you, that's all that I have for you today.